Okay, let's start. Good morning, developers. Thank you for being here today. I just passed by the lunch and see there was some good food, so I appreciate you choosing this talk instead of eating something. My name is Mattia Dell'Oca. I work at SUPSI, which is one of the universities of the city of Lugano, and I work in a research institute called EASIN. My main focus of research is blockchain technologies and decentralized technologies in general. So I would like to tell you a story, which is what I've been doing as a developer during the last year. I was tasked with solving an issue related to trust. In fact, there was this scenario in which we had companies operating on opposite sides of the world. And these companies don't know each other directly, but they put some trust in a consortium that they are both part of. So if we want to solve this problem using decentralized technology, how can we do that? This is the answer that I would like to answer today because I think it might be useful for you, and the solution proposed will be likely used by you as well, whether you know it or not in a few years. As you can understand, today's topic is regarding identity. I think we all know what it is, but just to give a quick definition, identity is what makes us unique and differentiate us from others. We all have some qualities that make us different, and these qualities can be resumed inside credentials. We all possess and use credentials. There are two types of credentials, the first being physical. So for example, I have a physical credential here that identifies me as an employee of SUPSI. What is good about physical credential is that I am sovereign of the credential itself, meaning that I am the one who decides who I want to share the credential with, and I can decide whether to do that or not. At the same time, physical credentials cannot be used inside online scenarios, at least not easily, and they also lead to identity fragmentation. I guess you all have plenty of physical credentials in your wallets saying the same thing all over again. For example, I have multiple credentials saying that my name is Mattia, I was born here on that date, but I need these different credentials for different use cases. Another kind of credentials are digital credentials. These are made to be used online, and they can range from the easy username password authentication to more complex scenarios, such as the usage of an identity provider. What an identity provider does is basically acting as a grantor, and if you want to access a service, but you don't want to create an identity for that specific service, let's say you want to register for a blog, but you don't want to create an identity specific to that blog, you can use an identity provider, so let's say Google or Meta, to authenticate on that online service without having to create a specific identity. The problem with the usage of identity providers is that you are no longer sovereign of your own identity, meaning that the identity and the credentials are managed by the identity provider itself. You don't know exactly how it acts. You can only wish that everything that the identity provider does is in your best interest. So when I had to create this identification model, I asked myself, can I take the best from both solutions? I would like an identification model which has the following 5 properties. The first one being sovereignty, meaning that because I possess my identity, I should be the only one being able to manage my own credentials. Then we have authenticity. I would like to know if a credential is, let's say, valid, by determining this with a strong mechanism such as encryption, which makes, let's say, tampering a credential very easy to detect and very hard to do in a successful way. Then we have usability, meaning that the credentials should be used both online but also in the real world. Availability, meaning that I don't want a single point of failure, such as, for example, an identity provider, which might become unavailable for a technical failure, let's say. And finally, I want to be able to revoke credentials, because think about if your wallet gets stolen, you will want to block your, let's say, credit cards before someone uses them in a not authorized way. So if we talk about identification system, we are referring to a model called the trust triangle. Don't worry, it's actually quite trivial. It is made of 3 different entities, 3 actors, the first one being issuers, which are those emitting new credentials, let's say the state, a bank, a university, and so on. Then we can find holders. all of us are holders because we possess credentials and we are described by said credentials. And finally, we also encounter verifier. A verifier is basically someone who grants you access to a service if you can authenticate. So let's give a brief example. Let's say that I want to buy some beers. I can go to a store, but the store manager may ask me to prove that I'm 18 years old or older, and this actually still happens to me, which is quite weird, but I guess it's okay if people think I'm younger. And what I do is basically giving them my ID card, and they can check that, in fact, I am 18 years old or older, and the store owner trusts the issuer of the credentials, so for example, the state. One identification model I would like to talk about today is called self-sovereign identity, or SSI. This is a decentralized identification model, meaning that it uses a peer-to-peer network to remove intermediaries such as identity providers. The idea behind SSI is to give full control to holders over their own credentials. And for doing this, it uses 3 building blocks. The first are decentralized identifiers. They are basically the component responsible for the encryption and security part inside a connection. These DIDs are made public to anyone by using distributed registries. These are, let's say, for example, blockchain technology, but it doesn't have to be a blockchain. It's not mandatory. And all the information inside this registry are public to anyone. So it's important to notice that your credentials, for example, are not stored there for obvious reason, but rather on your mobile phone, for example. These credentials are called verifiable credentials because they can be cryptographically provable. So even if I own my credential inside my phone, I cannot tamper and modify it because otherwise it will be evident because of the cryptography involved. So I told you that we will probably be all using SSI, and this is because you may not be aware of it, but in a few years, both the Swiss Confederation and the European Union will release their passport and their IDs for the citizen using the SSI technology. So I think it's good to have at least some basic understanding of this. Now, because we are developers after all, we might be interested in getting a more, let's say, hands-on approach to SSI and understand how we can implement it. I think you have to ask yourself 4 questions. The first one, what is the model I want to represent? Meaning, who are the actors involved inside my identification model? How do they operate? How do they interact with each other? What are their roles? Then, what should your verifiable credentials say? What should be contained in them? Aside from that, if we have multiple credentials, let's say, how should they operate between each other? Are they somehow related? And finally, because you want to revoke credential if needed, how can I do this? I would like to use the initial use case as an example for answering these questions. Maybe you don't remember, but the use case was companies on different sides of the world who don't know each other directly, but they want to start some kind of negotiation, and they put some trust inside a consortium. So if we try to apply the trust triangle to this scenario, we can determine who is going to be the issuer, who the holder, and who the verifier. Inside our use case, the first issuer is the consortium, who is, let's say, emitting credentials to new companies joining the consortium itself. But then, if you think about it, companies are again issuers because they emit credentials to their employee, let's say. Therefore, we have 2 trust triangles, and one is nested in the other, basically. Now, if employee 1 from company 1 want to start a negotiation with, let's say, employee 2 from company N, they might not know each other directly, the companies might not know each other, but even if we are in a decentralized scenario, because they have some common trust in the consortium, we can solve the issue of trust. A topic I would like to introduce is delegation. If you think about how a company operates, it's not a physical person who acts on its own, but it's rather an organization that acts through the company employees. This means that the employees of a company have specific roles and permissions that tell us what an employee should be able to do. So let's say an employee might be able to start a new negotiation, but not to fire someone just because they have had a discussion the day before. Now, if we think about the credentials that should be used inside this scenario, we have two different types of credentials. The first are the credentials representing companies. These are issued by the consortium. And now every company can issue credentials to their employees, describing the employee itself. If you think about what identifies an employee in this scenario, you can understand it's not just the employee credential, because it's not sufficient to know that a guy called Michael Scott is an employee. You have to know that he works for a company which is part of the consortium. So you need this union of the two information. And this results in the need to grant both credentials to the employee, because otherwise it will not be sovereign of its identity. Therefore, the employee possesses both credentials, but now you may think, well, what if the employee is not trusted anymore? Let's say that Michael starts doing some inappropriate jokes, therefore you want to fire him as Dunder Mifflin. What can you do? The answer is credentials can always be revoked, and this can be done by marking the credential as no longer valid inside the distributed registries, which make information public to anyone. At this point, if someone was verifying the credential, they will be able to understand that the credential is no longer valid. Now, I would like to show you a brief demo of the application. Here on the left, I have the platform that companies use to start negotiation, and on the right, I have my phone, which contains my credentials. So let's say that I am an employee who wants to log in on the website. I will use my wallet to share my credentials, and now there is some additional stuff going on. First of all, I'm required to accept a Wallet Connect session. This is not strictly related to SSI, but if you are used to Web3 technologies, you may recognize it. Now, finally, the consortium is asking me to present credentials which are valid, so I share the credential of my organization, and now here I have multiple employees for testing purposes, but let's say I share the credential of Michael. Now something else will happen, which is I will be required to sign a specific message which is needed for something else which is called deriving an identity on another chain, and I'm not sure why it's not happening right now. I think I have some problem with my connection, but fortunately I have a demo here. What will happen is basically that at the end, I'm able to share my credentials with the platform, and now the platforms know all my information, but I am the one detaining them. And also, inside this specific project, we are managing the SSI identity using an Ethereum private key, so we can also write a transaction inside Ethereum, and, for example, on another chain, which is called IC. Finally, we can get to advantages of the solution. If you still remember the properties I told you about at the beginning, as the name self-sovereign identity kind of gives it out, we are sovereign of our credentials because we are detaining them inside our phone, so we are those in control to manage them. Then you can prove authenticity of credentials by using asymmetric key encryption. So if you try to tamper a credential, this operation will be obvious to anyone. Credentials can be used online, as we saw during the demo, but they might be harder to be used in the physical world because you will still need a phone, maybe a connection. So probably a physical credential will be easier to use in this scenario. Regarding availability, we are inside a peer-to-peer network, meaning that there are no single points of failure. And finally, about revocability, credentials can be revoked at any time if the need to do so arises. Of course, we also have some disadvantages. First of all, because our employee is now more powerful, being sovereign of their identity, they also have greater responsibility. So let's say that an employee forgets his private key, loses it. It will not be as easy as in a traditional system to say, oops, I forgot my password, can someone please reset it for me? It will not be so easy. And overall, because we are in a decentralized system, it is more complex than a centralized one. And this is needed in this case for creating trust, but trust me, it will be harder to manage the system overall. I would like to share some personal thoughts about SSI. First of all, I would like to talk about decentralization. You may ask yourself, is full, complete decentralization is let's say, reachable? If you are particularly into a chain that starts with B and ends with Bitcoin, you may say that everything else is not decentralized. And while I don't necessarily share the same opinion, I think that full decentralization is not achievable because you may trust fully your software, but you will never be able to don't trust verify, let's say, your hardware. But beside from that, decentralization is very hard to manage, but sometimes needed, such as in this use case. But if you can solve a problem using centralized technology, then I don't think you have a reason to consider decentralization. Another thing is that SSI doesn't necessarily need a blockchain. As I was explaining you, it uses a distributed registries, but one solution could be that every entity has a public website and write their DIDs, so their cryptographic information inside the website itself. If you want to learn more about the topic of SSI, here there is a quite well-written book on the topic, which gets periodically updated. And finally, if you want to know more about the development part, Vramo is probably the best framework around I found so far, so I suggested that. Finally, when do I suggest you to, let's say, use or at least consider SSI in your project? First of all, you have to be open to use newer technologies who, of course, are more immature and could, let's say, have more failures than more affirmed one. So if you don't want to use a technology that is not has been an industry standard for the last 10 years, SSI is still too young for this. But on the other side, if you're interested, I would like to ask you how the aforementioned properties are relevant to you, because I think that if they are absolutely critical, you will not be able to guarantee them without a traditional identification system, and therefore SSI might be one of the alternatives. Also, if you already work using blockchain technology, you may have faced the problem of identification, and I think that SSI is the best way to solve it, as you can easily link a private key, let's say on Ethereum or another chain, with verifiable credentials. So this was it for this brief talk. I hope you liked it, and I'm here to answer your question. If you want to keep in touch, here you also have my LinkedIn profile. Otherwise, you can ask me whatever you want, for example, outside. Thank you for your attention.
Any question from the audience? Could you please re-explain in the trust triangle, what does it mean when the holder needs to trust the verifier? Like what does that mean, they trust the verifier?
It's more the verifier that needs to trust the issuer because, as again, in the example before, a shopkeeper might trust the state, but if it's a credential that I just made up, they will not trust the issuer of the credential.
All right, sorry, when the holder trusts the verifier. So what does that mean, that the holder trusts the verifier?
I guess it's more in general that I think that I would like to access your service, and when I share your credential with you, you will not use it to do something, I don't know, sketchy or something you should not do. So for example, if it's an online website that you don't really trust, probably you wouldn't share their credential, your credential with them.
Thank you.
You're welcome.
Maybe just a more detailed question. You have two types of credentials, the company and the employee ones. But in your scenario, would the employee, would the consortium have to issue company credentials to each of the employees of all the companies, or how was that set up?
No,
because it's a delegation. You have first the trust protocol, and then you kind of have the companies issuing the employee credentials.
So it's the consortium is only responsible for issuing credentials to companies, and then it's the company itself that issue credentials for the employee. But let's say that maybe the consortium doesn't trust a company anymore. If you revoke the credential of the company, then if you don't have, you are in this scenario where you have the two credentials, they both need to be valid. So an employee will not be able to join the consortium if the consortium has revoked the company credential.
But still, these are going into wallets as well, the company credentials.
Yes.
So each employee ends up having one of those.
Yes, you can basically take a copy of a credential, and you, of course, do that only if you trust the entity. So let's say the company trusts its employees, so the company makes a copy of the credential, and every employee has it. The problem is that you have to give both credentials to the employee, because otherwise, if the company holds the credential and not the employee, how can the employee be verified in, let's say, a sovereign way, so without having to contact the company inside the authentication?
Okay, thanks. I mean, there's also some other protocols like VLAY. I don't know if you heard of that. Virtual legal entity, where you can model these relationships. So that's maybe something to look at. But anyway, thanks.
Okay, thank you.
Any other question from the audience? Otherwise, let's thank the speaker again. And good lunch.